India has long harbored the ambition of becoming self-reliant in defense technology, a goal closely tied to its strategic autonomy and national security. Among the most formidable challenges in this journey has been the development of a state-of-the-art fighter jet engine. For decades, India has relied heavily on foreign suppliers for aircraft engines, a dependence that has imposed limits on its indigenous defense programs and constrained its ability to upgrade or export military platforms independently. But in a dramatic turn of events, India is now on the cusp of a transformative breakthrough, one that could redefine its position in the global defense ecosystem and significantly enhance its military capabilities. The development of a fighter jet engine is no small feat. It demands the convergence of multiple high-end technologies, precise metallurgy, advanced materials, thermal dynamics, and the ability to withstand extreme operational stresses. Globally, only a handful of countries, the United States, Russia, the United Kingdom, and a few European consortiums, have successfully developed and produced combat-ready jet engines. India's persistent efforts to join this elite club have spanned over 3 decades, with the Gas Turbine Research Establishment (GTRE) under the aegis of the Defence Research and Development Organisation (DRDO) leading the charge. India's initial foray into this domain came with the Kaveri engine project, launched in the 1980s. Conceived as an indigenous power plant for the Light Combat Aircraft (LCA) Tejas, the Kaveri project faced a litany of technological hurdles and delays. Issues with thrust generation, weight, material performance, and integration with aircraft systems plagued the project for years. Critics labeled it a failure, but the experience provided an invaluable learning curve for Indian scientists and engineers. The lessons drawn from Kaveri laid the foundation for future endeavors, both in terms of technical refinement and project management. Fast forward to the 2020s, India has taken bold steps to reinvigorate its engine development efforts. Through strategic collaborations, knowledge sharing, and infusion of private sector innovation, the Indian defense ecosystem has grown more mature and capable. One of the key turning points has been the renewed focus on developing a high-thrust jet engine capable of powering India's future fighter aircraft, including the Advanced Medium Combat Aircraft (AMCA), a 5th-generation stealth fighter being developed indigenously. In a remarkable convergence of effort and opportunity, India has made significant progress in high-temperature materials technology, single-crystal turbine blades, and ceramic matrix composites, critical components that determine an engine's performance and durability. This progress has been accompanied by the establishment of advanced testing facilities and collaborations with international partners for specific technologies, all under the watchful framework of the Make in India and Atmanirbhar Bharat, Self-Reliant India initiatives. Perhaps the most notable aspect of this breakthrough has been the technological synergy achieved between government agencies and private sector innovators. Indian industry leaders, including major players in aerospace manufacturing and materials engineering, have come together to create a robust supply chain that can support the complex demands of jet engine production. This ecosystem has started producing high-precision components such as compressor blades, combustion chambers, and control systems, with tolerances measured in microns, an achievement previously considered out of reach. Another crucial development is India's investment in computational fluid dynamics (CFD) modeling, simulation technologies, and digital twins to optimize engine design and performance before physical prototypes are even built. These digital tools have drastically reduced development time, improved efficiency, and allowed engineers to fine-tune design parameters in real time. Furthermore, the integration of artificial intelligence in diagnostic systems has enabled predictive maintenance and enhanced engine reliability, features that are critical in modern air combat scenarios. The breakthrough also carries profound geopolitical implications. By achieving indigenous fighter jet engine capability, India gains greater independence from foreign technology embargoes and political leverage often wielded by engine-supplying nations. It opens up the possibility of exporting fully homegrown fighter aircraft without third-party restrictions, which could boost India's defense exports and establish it as a credible player in the international arms market. Moreover, this success symbolizes more than just technological progress. It is a testament to perseverance, strategic planning, and the long-term vision of India's defense policy. The ability to design, test, and produce a combat-worthy jet engine within Indian borders signifies a new era of self-confidence and national pride. It also sends a strong message to adversaries and allies alike that India is not merely an arms importer but a rising power capable of building sophisticated military systems from the ground up. International recognition of India's achievement has started to trickle in, with defense analysts and aerospace experts acknowledging the significance of this milestone. Some compare it to a moonshot moment in defense technology, an advancement that few expected to see in such a short span of time. The implications extend beyond military use as well, since many of the technologies developed for fighter jet engines can be adapted for civilian aviation, space propulsion, and high-performance turbines used in power generation. What makes this breakthrough even more impressive is that it has occurred in a global environment of tightening export controls, complex geopolitical alignments, and fierce competition in defense R&D. Against these odds, India has not only persisted but succeeded in breaking the glass ceiling that has historically separated engine producers from engine buyers. The journey is not over. Rigorous flight testing, operational deployment, and continuous improvement will follow, but the foundation has been firmly laid. As India moves forward, the world watches closely. With the AMCA program gaining momentum and the prospect of a new generation engine powering it, the Indian Air Force is poised to enter a new phase of air superiority. Future versions of this engine may even power unmanned combat aerial vehicles (UCAVs), hypersonic platforms, or collaborative combat aircraft, pushing the boundaries of what indigenous defense capability can achieve. Ultimately, India's fighter jet engine breakthrough is more than a technological achievement. It is a declaration of capability, a statement of intent, and a beacon for what is possible when a nation sets its sights on a bold, seemingly impossible goal and commits to the long, hard road required to achieve it.